Section 5.2, Chapter 5. Now, we're introducing one more formula, and that is if you have more than one exponent, you always multiply the exponent. So if you have 5 to power of 2 and the whole thing to power of 3, see, in this case, there are 2 exponents. So shall I write this as 5 to power of 2 to power of 3, 8, or 5 to power of 6? According to this formula, you are multiplying these two. So you don't write it as 5 to power of 8. Now, if I don't know anything about this formula and I want to do this, 5 to power of 2 and the whole thing to power of 3 means this. Look, means you take 5 to power of 2 and multiply by itself 3 times. So then what do you have? See, you have 5 to power of what? 6, okay? So when you have more than one exponent, you could always multiply the exponent. Two a to power of 3, b, c to power of -4, and the whole thing to power of -6. We want to simplify this. Now, I need a power for 2. If you don't see any number, the power is always 1. So the first one, the power is 1, then it's 3, then it's 1, and then -4. So 1 by 1, you write it 2. Power of 2 is 1. 1 times -6, see? Three times -6, which is -18. 1 times -6. And c times -4 times -6 is 24. So first we multiply all the powers. And let's give a denominator of 1 so we create a fraction. Now remember the formula that if you have a negative power, you always reverse it as a positive. So here, these 3, they all move to the denominator y because they all have the negative power, right? But c to power of 24 remain there. So you have like this, okay? And if you want, you could write 2 to power of 6 as 64, if you want. there are two power, -1 and 2. You multiply these two, and then according to this formula, it's 1 over that or 1 over 36. So anytime you see a negative power, you need to reverse it as a positive. Now let's look at this problem. Power of 3, power is 1 times -1 is -3, -1. X, -8, y, -7. And then the rest, there is no power here. Okay, so you could just write it as 7x by 9. Now, if I create a fraction here, all the -1, they all move to denominator. Because they all have a negative exponent, right? So you have 7x y 9, 3x 8 y 7. I have x1 and x8. You simplify this. That would be x7 at the bottom. y7 goes to y9, and there is a y2 at the top. You want to simplify? Again, there are two power. One has a letter in it, the other one is a number. It doesn't matter. We understand that you always multiply the exponent. So when I distribute that would be, see in this one, you don't really come up with a number. You just understand this is 49a plus 21, that's it. It just shows that when you have power as a letter, it doesn't matter, you still follow the rule, right? Another examples. See? You distribute that. Okay, now we want to apply it to the fractions. You know, first, I want to get rid of these negative ones and make it positive. Because the power is negative, you bring it to the top. Okay. Now you have more than one power. You know, there are several ways to do a problem like this. You know, one is you could just first get rid of all the negative ones, or you could just go ahead and multiply by -5 all the powers. Okay, so what you have here is this. Look, at the numerator, you have x to the power of -35, because 7 times -5. Y to the power of 40, y is 40, because -8 times -5. Now, what you have at denominator is stay at denominator. See, z is at denominator, right? So you stay, z is stay at the denominator. -2 times -5 is 15. Now, the only one with the power of negative is x. That's the only one that you got to bring it here. So it would be y to the power of 40, x to the power of 35, z to the power of 15. Okay. Again, when you don't see any number, just put a power on. So we multiply all the exponent. 1 times 2, write the x. 4 times 2. Again, there is another x here. 7 times 2. x8 and x14. You remove 8x from this. So it would be what? 6. See, they don't have power of 1. So 1 times -2 and 1 times -2, right? Now you switch all the -1. So far, there are two formula that we are using, right? One is when you have a negative exponent, you change it to the positive, right? And what's the other one? If you have more than one exponent, you always multiply. So we have been using these two for section 5.2. And they all say, write the answer using positive exponent. The answer always has to be in the positive exponent. You don't want to leave the final answers as a negative exponent because it's meaningless. When you have a negative exponent, I cannot take a number and multiply by itself negative times. That's why they're saying make sure the final answer has a positive power. Again, you multiply all the powers. See? That's all you need to do is just multiply all the powers. So all I have is the positive exponent. Any negative exponent, always switch it to 1. I need to switch all the negative exponents font. The ones that are positive, don't touch them. They stay where they are, whether they're numerator or denominator. Okay. Just the negative ones moved. Okay, so we'll do 25 over those numbers. So again, the two formula have been used for 5.2. You have more than one exponent. And when you have a negative power, you switch that to the positive power. Okay, so that would be end of that section.